The amount of trust that we put into devices we use every day is absolutely insane. In this video, we're going to talk about a crazy story where a security researcher found a way that he could not only hack into his own modem, but literally any modem that anybody used in his entire ISP's network. Also, if you're new here, hi, my name is Low Level Learning. I make videos about software security and cybersecurity. So if you're new here or just want to hang out with me, hit that sub button. 2 years ago, something very strange happened to me while I was working from my home network. This guy was doing pen testing, right? And he had this blind XXC, which is he's allowed to inject arbitrary XML and then use that to run command execution. And for it to happen, he had to have a different endpoint that he could point and download HTTP files from. So we went up onto AWS and spun up this server here. And once the web server was running, I sent a curl request from my home computer to make sure that it could receive external HTTP requests. So he sent this request to the server. And then just a few seconds later, I saw the following log. So, this is him tracing out the logs of that server, and you can see that this is his GET request. This is his curl request to that server. Perfect. This meant that I was able to receive network traffic on the box. Everything seemed good to go, but right as I switched back to exploiting the vulnerability, something very unexpected appeared in my log file. So you see his initial request here, and then there's a second request coming from a different IP address that was not his. He runs his initial request. You see his request hit the box, and then the exact same request hits the box from a different IP address that is not his. Very suspicious. All right. An unknown IP address had replayed the exact same HTTP request just 10 seconds later. Wow, that's seriously weird, I thought. Somewhere between my home network and AWS, someone had intercepted and replayed my HTTP traffic. The traffic should not be accessible. There is no intermediary between these two systems who should have seen this. My immediate thought was that my computer had been hacked and that the hacker was actively monitoring my traffic. He has his box, he has AWS. He's thinking that there's somebody in a box in the middle that can go in and see all of his stuff. Now, to check if this behavior occurred on a different device, I pulled out my iPhone. So originally he was on his computer at his house. Homie pulls out his iPhone and he typed in the URL to Safari and he sent the request and peeked at his log file. So again, this is his request, and then this is the same IP address doing the same replay attack. So it's not just his computer that could be hacked, it's also his iPhone. The same unknown IP address had intercepted and replayed both HTTP requests from my computer and my iPhone. Somehow, somebody was intercepting and replaying the web traffic from likely every single device on my home network. So then from a security standpoint, what does that mean? Either literally every device in your house is compromised by the same piece of malware, or someone in the middle is snooping on your traffic, or a device in the middle is compromised. It's a bit of a foreshadow you'll see later in the video. So panicked, I spun up a new AWS box running Nginx to make sure that the original instance had not been compromised somehow. So now he's thinking like, okay, was it that the server I was on that got hacked? So we made a new box, made Nginx, so not Python, just a regular Nginx server, did the same thing from his iPhone and saw the exact same log. So someone is sniffing on his data coming out of his house. It has nothing to do with that AWS instance. It's literally just, if it's coming out of my house, someone is replaying it. So something crazy is going on here. Through what could only be my ISP, my modem, foreshadowing, or AWS being compromised, someone was intercepting and replaying my HTTP traffic immediately after I sent it. To eliminate the absurd idea that AWS had been compromised, I spun up a box on GCP instead, another cloud provider, and observed the same unknown IP address replaying my HTTP requests, so it wasn't AWS. The only real option left was that my modem had been hacked, but who was the attacker? I queried the owner of the IP address and found that it belonged to DigitalOcean. Strange. It definitely didn't belong to my ISP. To kick off an investigation, I sent the IP address to some friends who worked for threat intelligence companies. They sent me a link to the virus total listing for the IP address, which detailed all of the domains which resolved the IP address over the years. Now, this was odd. The IP address just 1 year prior was being used to host phishing infrastructure that targeted a South American cybersecurity company. Assuming that they had been in control of this IP address for 3 years, it would mean that they had used it for at least 2 different phishing campaigns and is what appeared to be a CNC server for router malware. So again, this guy is thinking that his modem has been compromised and this IP address, which resolves to isglatam or whatever, is being used to see to that malware. So okay, something weird is going on here. Handing over the evidence. The modem that I've been using was a Cox panoramic Wi-Fi gateway. After learning that it was likely compromised, I went to the local Cox store to show them my device and ask for a new one. The one issue with this request was that in order for me to receive a new modem, I had to hand over the old one. Sadly, it wasn't actually my property. I was only renting it from the ISP. So classic ISP move where they put a device in your house, your device gets hacked, and when you want to look at it, they're like, sorry, that's not actually your device. We need to get it back. I explained to the employee how I wanted to keep it and reverse engineer the device. Their eyes shot up a little bit. They were much less enthusiastic about giving it back to me. So this is like, he went to a Cox store and literally there's a guy making like $18 an hour. And Sam Curry is like, I literally have uncovered a malware campaign that's targeting your ISP modem. Like, you have to let me keep this. And the guy's like running his checklist and it's like, it says I'm not allowed to let you do that. And so that's just like what happens. There's no way I can keep it, ? I asked. No, we need to take your old one and give you a new one, the ISP representative said. Again, Steve, he's at the end of his 8-hour shift. He's an hour and a half in and there's no budging. As much as I wanted to take it apart, dump the firmware, and see if there's any trace of whatever potentially compromised it, I had already passed the device off to the employee. I took my new device and left the store, disappointed that I wasn't able to do anything more with it. After setting up my new modem, the previous behavior completely stopped. My traffic was no longer being replayed. There was no other IP in the logs. Everything seemed fixed. So, guy is getting his internet traffic replayed, thinks it's the modem, gives the modem to Cox, Cox gives him a new modem, traffic stops. So without a doubt, there was a piece of malware living in his Cox ISP modem. If I say Cox again, I think I'm gonna get demonetized. Cox, 3 years later. So this is like in one of those movies where you see people, they have some event happen to them and they have to go through some traumatic life event and 3 years later they figure it out. This is literally what happened. So this guy is doing this research on his home device, getting hacked, getting his Cox hacked, and then 3 years later, he figures out a way to get through it. 3 years later, in early 2024, almost 3 years later, I was on vacation with some friends who also worked in cybersecurity. We were having a conversation over dinner when I explained the story to them. Curious to learn more, they asked me for all the details and thought it'd be fun to run their own investigation. The first thing that caught their attention, having worked on more malware analysis a lot more than I had, was the format of the two mail server domains. So it's this, and they're saying that basically every single domain that was registered by the discovered IP address used the same naming convention. So you have word, 6 numbers, and a top level domain. Due to the mass number of domains and algorithmic structure of the registered addresses, this appeared to be a domain generation algorithm used by malware operators to rotate the resolving address for the CNC server for the purpose of obfuscation. So basically, they're trying to make sure that you don't have a good pattern of life on the DNS record for that IP address. There's a good chance that the IP address replaying my traffic was a CNC server, and the two domains where I thought there were mail servers were actually algorithmically generated pointers to the CNC server. Something disappointing was that all of these domains were historical. The last one seen was registered in March 17, 2023. None of the hosts resolved anything anymore, and we couldn't seem to identify anything similar being registered to the same IP address. Given that my new modem was the same model that had been compromised, I was curious if the attacker had found a way back in. From a quick Google search, I discovered that there was no public vulnerabilities of the model of the modem that I had. The other option seemed more and more likely that they had exploited something outside of a generic router exploit. I was super curious to investigate this and try to brainstorm ways my device could have been compromised. So this is where the article gets absolutely insane. So things start to get pretty crazy here because this is where the TR69 protocol and the idea of an ISP being able to remotely control your device comes into play. But effectively, if you've ever had an ISP like work with your house, they can remotely control the device that they give you when they set up your internet. So if you have like a Verizon router, right, you plug an Ethernet cable into that Verizon router and the ISP can completely remotely control it, right? Something about that smells incorrect. And if it's not implemented correctly, bad things can happen. And are those endpoints TLS encrypted? Last loyal Raven, let me tell you, the answer is no, and you're about to find out why in this chat. Targeting REST APIs using the TR69 NICE protocol. After getting back home, a close friend had asked if I'd been able to help him move furniture into his new house. What this also meant was helping him transfer over his Cox modem after connecting his device to the fiber line. I went ahead and called the ISP support and asked if they'd be able to push out an update to allow the device to work in a new location. The agent confirmed that they could remotely update the device settings, including changing the Wi-Fi password and viewing the connected devices. Now again, this is where things get weird, man. Like, it makes sense that your ISP can help fix your device, can update the firmware, but the question is, like, how are they doing that? And what is preventing one person from doing that and not the rest of the world, right? Why is the ISP special? Now, the ability of support agents to control devices really interested me, especially since they could update pretty much anything on the device. This extensive access is facilitated by a protocol known as TR69, implemented in 04, which allowed ISPs to manage devices within their own network via port 7547. This protocol had already been the subject of a few great TEFCON talks and wasn't externally exposed, so I wasn't super interested in bug hunting that protocol itself. So typically, these ISPs are able to have different planes of management where even though the port is open, you can't hit it from the outside, only the ISP can. So in theory, that's not a great attack surface, which is why Sam didn't go after it. To theory craft a little bit, if I were a hacker who wanted to compromise my modem, I'd likely target whatever infrastructure powered the support tools that the agents were using. There were probably some internal website for device management that support agents used, backed by an API that could execute arbitrary commands and change view administrative settings on customer devices, foreshadowing, if I could find some way to access this functionality, it might shed light on how I might have been originally hacked and patch out at least one method for somebody to compromise my modem. The first thing that I decided to do was look at the Cox business portal. This app had a ton of interesting functionality to remotely manage devices, set firewall rules, and monitor network traffic. Nice, there's a basic login portal here. And again, this isn't internal to his house. This is just a regular page you can log into. And again, like, basically behind this wall of auth, if implemented incorrectly, could be a way to touch every modem that exists on Cox's network. Without actually having a Cox business account myself, I opened the login page for the portal and grabbed a copy of main.this that powered the core functionality of the app. After beautifying it, I parsed out all the routes and scrolled through them. So this guy, traditional hacker stuff, you're doing web exploitation. You have all these JavaScript files that are coded to reach out and touch certain endpoints. Okay, so let's see what those endpoints do. And you see we have here API, voicemail, transcribe message, user roles, verify contact, validate. And the assumption, guys, is that these are going to be authenticated, right? These are API endpoints that are going to be behind some kind of auth token that you as a regular user don't have. There were over 100 different API calls that all had the same base path of API CBMA. Since this route seemed to power most device-related functionality, I thought it was worth investigating if the API CBMA endpoint happened to be a reverse proxy to another host. I tested this by sending the following request. HTTP request that does not start with API CBMA returns a 301, so that's a redirect. HTTP request that does start with API CBMA returns 500. So from sending the above requests, we learned that API CBMA endpoint is an explicit route that is likely a reverse proxy to another host due to the differing behavior between the HTTP responses. Basically, this is a blind test where he has a hypothesis and he tests it by running two commands, and between the two commands he gets result A and result B, and by doing that he's able to prove that the backend is just a reverse proxy, and when it can't connect you get a server error. So since the API itself had all of the interesting device management functionality, it made sense to focus on everything behind the API CBMA route and see if there was any low-hanging fruit like exposed actuators, API documentation, or any directory traversal vulnerabilities that would allow us to escalate permissions. So right now he's trying to see what can I touch. I went ahead and proxied the registration request for the Cox business portal, which is underneath the API CBMA request. So basically, he is going to validate an email address request to this endpoint, right? He's basically testing, can I proxy arbitrary requests through API CBMA to run these functions, right? So he's running the validate if email v1 on email test example.com, and it says, okay, message success. So the HTTP request contained a bunch of different authorization headers, including what looked to be a generic use API key that was shared between users. Client ID and the CB session keys looked very custom and indicated that there were multiple roles and permissions used in the application. the HTTP response looked like a generic Spring response, and we can likely quickly confirm that the backend API was running Spring by simply changing the post to get and observing the response. So again, basic hacker stuff. He has a hypothesis, you change one variable, does that return the response you expect? And by changing the get to a post, he gets another 500 error, which means that he now knows it is a Spring related error. Spring is a server type that is very common to host these REST endpoints. Now, since we could confirm that the reverse proxy was running Spring, I decided to look for actuators and exposed API docs. I went ahead and tried the actuator route, and again, these are all just Spring internals. So now that he knows the type of framework that is being used here, he can follow the patterns that that framework typically uses and get some kind of information out of it, right? So he's trying to enumerate all the actuators, trying to enumerate all the documentation, and eventually he does hit a Swagger UI index of HTML. So eventually what happens here, he's able to enumerate these API endpoints, and he sees, literally by doing this, he's able to see all 700 different API calls. The Swagger routes had loaded. I used the same trick to load all the Swagger docs on all the other API endpoints, and in total, there were 700 different API calls, with each API having the following number of calls. And these are literally every endpoint that is exposed on the Cox business network. Yeah, so this is where the article takes a wild turn. So here it's looking like, oh, the API dev forgot to turn off Swagger. Like Swagger went to prod, so now you can see all the endpoints. Oh, boo-hoo. But surely the authentication is good. I mean, surely you need to have an access key that only an admin can have to get into this thing, right? Accidentally discovering an authorization bypass on the Cox backend API. After the intruder scan of all the API endpoints completed, I scrolled through to see if any had any interesting responses. The following profile search endpoint had an interesting HTTP response, which appeared to be a blank JSON object from what looked like to be an empty search. So he searched for profile search. He did not provide any data. And because there was no data, he got a response back that said success, 0 hits. So looking at the JavaScript, it seemed that we needed to add an argument to the URI for a profile to search for. He added that URI and searched test in the URI and got the following response. Message, authorization error, invalid user token. Invalid user token, but I had just been able to hit this endpoint. I removed the word test from the URI, resent the request, and another authorization error. For some reason, the original endpoint without parameters was now returning an authorization error, even though I just hit it when running intruder. I did a sanity check and confirmed that nothing had changed between my request in intruder and the repeater request. I replayed the request one more time, but surprisingly this time it gave me the original 200 okay. And the JSON response from intruder, what was going on? It seemed to be intermittently giving me authorization errors and then saying the request had been successful. So what it sounds like is internal in this system, there are multiple servers and it's doing like round robin load balancing. And every once in a while he is hitting a server where the authorization is just not correctly set up. Like it is just a naked server that anyone can go in and touch the endpoints without a user token. Now this may be because there's some weird caching issue going on where maybe someone somewhere else made a successful request and then there's like a NAT translation in the middle where like it sees that authorization session coming from the right server. But either way, this person is able to run these queries by typing in, by doing a profile search, and they redacted all this shit. But to test it, to test if I could reproduce this with an actual search query, I wrote down Cox in the URI and replayed the request 2 or 3 more times till I got the following response. And he got success, he got 10,000 hits, and he gave him a search list. And even crazier, these looked like profiles of Cox business customers. Not really expecting results, I replaced the word Cox with FBI to see if it was polling actual customer data. And you're seeing there's FBI redacted, FBI redacted, FBI redacted. The above response contained the physical addresses of several FBI field offices who were Cox business customers. The administrative customer search API was working, not good. So he not only found an API, he thought, oh, I don't have auth on this API. Surely it's just a test API where there's not real data behind it. And so as kind of a joke, he puts FBI into the search and he got legit like FBI sites in the request. So we had confirmed there was an auth bypass for the API endpoints by simply replaying the HTTP request multiple times. And there were over 700 API requests that we could hit. It was time to see what the real impact was, and this is where the article kind of like boils to the top, and you can just smell the hacker grease, the hacker essence. Not that hacker grease. Sam's a great guy. I looked back at the results of the intruder scan, now knowing that I could bypass authorization by simply replaying a request. In order to figure out if this vulnerability could have been used to hack my modem, I needed to know if this API had access to the residential network at an access control level. Cox offered both residential and business services under the hood. I was guessing the underlying API had access to both. I went ahead and pulled out the simplest looking request that took in a MAC address parameter to test if I could access my own modem via the API. And I just think this article is crazy because it goes from 0 to 100 so fast, dude. It goes from, I can query if a profile exists in the Cox database to, I'm gonna see if I can change settings on my modem via the MAC address. Like, what? This was a GET request to retrieve a modem IP address that required a MAC address parameter. I logged into Cox, retrieved my own MAC address, and then hit the HTTP request over and over again until it returned 200 OK. So it returned this, right? And so what is this? This request is account equipment v1 equipment. He puts in his account number, and it returns a list of all the Cox equipment that is on premises at this guy's house. It worked. My connected equipment was returned in the HTTP response. So like by using his MAC address and unauth, he was able to query if he had a Cox business TV, a telephony device, a Cisco router, a Cisco phone, a Nokia ONT, a fiber network transmitter. Like, yeah, dude, it's crazy. Accessing and updating any Cox business customer account. To test if this could be used to access and modify business customer accounts, I found an API request which could query customers via email. I sent the following HTTP request and saw the following response. So we put API, this whole thing, trying to query what the user data is, and he put admin@cox.net, and he got legitimate data. He redacted a lot of it, being a good responsible hacker. But yeah, this guy was able to use the endpoint, and he literally queried admin@cox.net, and other similar post account update requests worked. So he was able to read and write business accounts. Another similar post account update worked, and we already read this. So at this point, I demonstrated that it was possible to 1, search a customer and retrieve their business account PII using only their name, 2, retrieve the MAC addresses of connected hardware on their account, and then 3, run commands against that MAC address via the API. So you can completely not only enumerate your network, but run commands via MAC address. It's not RCE yet. Someone just said in chat, retrieve crypto private keys. So if this were done properly, this would be okay if there were a keying scheme where the company had a private key, the other end had a public key, you sign the request with the private key, and then you decrypt it, you verify the digital signature, and you say, okay, it came from the ISP. Overwriting anyone's device settings via a leaked cryptographic secret. And looking through the Swagger docs, it seemed that every hardware modification request, for example, update device password, required a parameter called encrypted value. If I could find a way to generate this value, then I could demonstrate write access to modems that would lead to remote code execution. Now again, in terms of basic cryptographic primitives, if you know how cryptography works, if you are trying to authenticate that a response came from your ISP, you would use a signing scheme. A signing scheme uses asymmetric cryptography, things like RSA, elliptic curve, under the hood to exchange a signature that you then verify with the public key. A cert would be enough? Yeah, exactly. They could use a cert. They could do something like this. Okay, so to know if I could even generate this encrypted value parameter, I had to dig through the original JavaScript to figure out exactly how it was being signed. And again, he's using the word signed here. And I think as you're getting from my inflection of my voice, it's not going to be a signing scheme. After tracing the encrypted value parameter back to the JavaScript, I landed on these 2 functions. Yup, in JavaScript, both of these functions took in variables which existed at runtime. So the easiest way to actually call these functions would be to find somewhere that it was called using the actual API. And after searching for a little while, I realized that the 4-digit PIN I set was registering my account was encrypting using the same function. Now that I had a breakpoint set, I was in the correct context for the function, I could simply paste the function into my console and run whatever I wanted. So again, this is the issue with doing critical functions on the front end, because the code is not closed source. You could have done this on the modem. You could have done this somewhere else where there is a hardware root of trust. The hardware root of trust stores the key, and then the kernel retrieves the encrypted data from the hardware root of trust. There are so many ways you could have done this differently, but they're using a symmetric key scheme on the front end to access the API. Okay, let's keep reading. To validate that it worked, I copied the encrypted value of the pin code that was set to the post request and passed it to the decrypt function. So he decrypts this. He takes the value that was sent to the API, he decrypts it, and out pops 8042, which is his pin. Perfectly, it works as expected. The only issue now is getting the encrypted value of a device. So where is that device encrypted value? I asked around for a while until I found a friend who owned an MSP a few states away. He used Cox Business. They gave me the login to their account, and I saw what appeared to be an encrypted value parameter in one of the HTTP responses after authenticating into their account. So this guy logged in. I copied the value and passed it into the function once again, and out pops this long string of data. And something in here is a little suspicious. This looks like a MAC address. Okay, let's see what's going on. Well, that's annoying. It looked like the encrypted parameter had the MAC address, but also an account ID and a few extra parameters. So within this encrypted value that his friend got from the API request, it had the account number, the device name, the device ID, something unknown, a label, and a MAC address. If there was some validation with check the MAC address attached to the account ID, it would make exploiting this somewhat complicated. I investigated further. On a leap of faith, I tried signing, and again, the issue here is he's using the word signing. There is no signing happening here. It is decryption. I'm not shitting on Sam, I'm just saying, like, you could do this semi-correctly if you had a proper signing scheme, but they're using AES. I tried a signing encrypted value string with the junk data for everything. So he's basically not caring about any of this data except for the MAC address, which is the MAC address of a device he wants to attack. To see if it actually validated that the account ID matched the MAC address. If this request worked, it meant that I could use encrypted value parameter in the API that didn't have a matching account ID. I sent the request and I saw the exact same response as above. This confirmed that we didn't need any extra parameters. We could just query any hardware device just by knowing the MAC address. We now essentially had a full kill chain. I formed the following HTTP request to change the SSID of one of my own devices. So here he's changing the SSID of his device via this endpoint to the name Curry. Okay, he got a success message, and sure as shit, after 5 minutes later, my network rebooted and the SSID name of my device had been changed to Curry. I could read and write anyone's device via this exploit. Absolutely wild. This demonstrated that the API calls to update device configuration worked. This meant that an attacker could have accessed this API to overwrite configuration settings, access the router, and execute commands on this device. At this point, we had a similar set of permissions as the ISP tech support and could have used this account to exploit the millions of devices that were accessible to the APIs. So the total impact is that the series of vulnerabilities demonstrated in a way which a fully external attacker with no prerequisites could have executed commands and modified the settings of millions of modems, accessed any business customer's PII, and gained essentially the same permissions as an ISP support team remotely from your house. And so eventually they did take this, they reported all of it by responsible disclosure, and he didn't publish this article until Cox went through and fixed it. Cox actually did a very good job, and I think they fixed the issue in a matter of like a month or two, which is really, really solid. But it's just truly insane. So after reporting the vulnerability to Cox, they investigated if the specific vendor had ever been maliciously exploited in the past, and they found no history of abuse. They had also informed me that they had no affiliation with the digital IP address or the DigitalOcean IP addresses, meaning that the device had definitely been hacked and just not using the method disclosed in this blog post. Anyway, thanks for reading. More than happy to listen to any theories, comments, or whatever about what happened here. Feel free to reach out at samwcurry@gmail.com. I think what probably happened is that someone else figured out this vulnerability in the API. They use this API to do some kind of command injection vulnerability. Every device that can be touched by this endpoint has to process that data. Or there could be a command injection vulnerability in any of these fields that he now can touch via these endpoints. Like, there may not be necessarily a run arbitrary code endpoint on this API. That device has endpoints that only that API could hit. If that API could touch any of the code in there, and there's a simple system command injection in that code, then, I mean, you're basically just opening up the attack surface for other bugs that could exist. And I think that probably is what happened. Now, why they're replaying the HTTP requests, like in the order of like 10 seconds or 5 seconds, that I don't know. That's really weird. But yeah, man, it's super weird. Anyway, go show Sam some love, and then hit that like button and that sub button, and then go watch this video about how, what was my last video? Shit. Then go check this video out about Microsoft Recall. It's pretty crazy. We'll see you guys in the next one. Take care. Bye-bye.